School Freeware's Visual Basic Express 2010 Tutorials. Tutorial 28. Multi-dimensional and parallel arrays. A short time ago, I came into contact with an application that required use of multi-dimensional arrays when the application really should have used parallel arrays. So for this tutorial, I would like to go over the situation that occurred within this application. So here we basically have the application. I'll go ahead and run. So this part of the application looked pretty simple. However, because of the multi-dimensional requirements, it became kind of cumbersome. So let's go ahead and move this off to the side for a moment. First of all, we have our multi-dimensional array here. The multi-dimensional array is set as double because of the requirements set forth. However, the quantity, as we would have expected, should be an integer instead of a double floating point data type. However, within Visual Basic 2010, we can still use the double data type and quantity will still work, even though it should be an integer. Next, we have the prices loaded up, the quantity, and here for the text box append, these VB tabs is basically the same thing as hitting the tab on the keyboard. So we would have quantity, tab, price, tab, total. So it'll come out looking pretty nice there as a header for each column. Within the for loop, here we have total, so we have the quantity multiplied by the price. Unfortunately, when printing out, one of the requirements happened to be that the quantity was set to section 2 of the multi-dimensional array, as you see here. However, the requirements wanted to print it out first, so therefore we had to put the second part of the array first, as seen. The .toString converts the section of the array to a string, so this would be a double converted to a string. And here we have, and within quotation marks, C, which stands for the currency formatting, which would allow the computer to put the currency symbol, in this particular case a $, before the number. So here we have the price, and the total is also set for the currency string conversion. One of the problems within the multi-dimensional array, as mentioned before, is that the multi-dimensional array uses a number, and you have to remember that price comes first, set by quantity, and then be the total. So there's a few problems, but we were able to get through it without too much difficulty. Within this program is basically the same thing, with the exception that parallel arrays are used. So here we have an array for price, an array for quantity, and an array for total. Load the price, load the quantity, and here we have the total. And what's nice about using the parallel arrays is everything is labeled. So here, if we wanted to have the quantity printed first, we just simply print the quantity followed by the price, converting it to the currency format, and then finally we have the total. So everything here looks pretty nice. Now let's go ahead, close down the multi-dimensional array application, and I'll go ahead and run the one using parallel arrays. As far as the user is concerned, there's no difference between the two. However, the parallel arrays are much easier to work with as far as the coding is concerned. Now let's say, for example, here we go ahead and run the program, and we find that we really don't know what item each line represents. So therefore we want to add a name to each line indicating which item is being printed there up on the screen, whether it's hats or shoes or whatever it happens to be. So I'll go ahead and close this down, and here we have basically the same program to add names to the multi-dimensional array. It will be a 4x4, and we'll set it as, well, double, but unfortunately here we need to have a string for our names. Well, let's go ahead and see if it works. Go ahead, run. Well, maybe if I scroll up and change this to a string, stop the program and try running it again. We get an error down here, and string doesn't seem to want to work. Maybe if I were to stop this program and leave it blank, see what happens. Go ahead, run. I still get an error. And it seems to point out this toString conversion. So maybe if I got rid of the toString and just put in a standard string conversion, str, wherever I need. And inventory 4 is the name, so that doesn't need to have any string conversion because it's already a string, supposedly. So I'll go ahead and run, see what happens. Ah yes, it runs now, but we lose the $sign because we lost the string formatting. What has basically taken place by leaving this blank is that we're really using an object, a data type, which is much slower than using other data types. On older versions of Visual Basic, it's also called a variant. If I were to try to use a variant, automatically the computer changes it back to object, which is the new data type name. Go ahead, run, and yes, it works with the object. Again, we lose the $sign, and the program is a little more cumbersome to code and understand of what's going on. Finally, we get to the parallel arrays, where we have the name array added to the application. And you see here, using the parallel arrays, we can also have different data types, one for each array. So therefore, the quantity is set to integer, the name is set to string, and the total and price are set to double. Again, much easier to read. We print the name first, quantity, price, total, and we can also use the string currency conversion format. So go ahead, run. And as you can see, using the parallel arrays when it is necessary to use a parallel array works a whole lot better than trying to use a multidimensional array. Multidimensional arrays have their purpose, but if you're using them within parallel, as you can see here, all the arrays are running parallel. It is much better to use a parallel array than try to use a multi-dimensional array.